Hello my dear children. As you know, we have started chapter solution, unit 2 of class 12th. Yesterday we have completed Henry's law. Now today topic is, write down the topic is, hope you have NCERT in your hands as well as notebook. Write down the topic of today's is after Henry's law, vapor pressure of liquid solution. Today the topic is vapor pressure of liquid solution. And very first today I told you what is liquid solution, when the solvent is liquid. This is my first lecture when the solvent is liquid. And I even told very first today solvent is that which is in excess and solute is that which is in small quantity. Solvent. So now you can see here liquid in liquid, solid in liquid, gas in liquid. These three are the liquid solutions. Liquid solutions. Liquid solutions are those when the solvent is liquid. Solvent is liquid, liquid in liquid. I told you alcohol in water, solid in liquid. My first lecture it's a common example, NaCl in water, gas in liquid, it is carbon dioxide gas in water. It is all we have discussed. Now today we will take the vapor pressure. Vapor pressure is a pressure. Vapor pressure is the pressure you can write down. It is a pressure exerted by vapors on the liquid surface at equilibrium. So this is my liquid solvent. This is liquid. So I have taken a part, liquid in liquid. Today I am taking vapor pressure of liquid solution and this is liquid in liquid. Today we will discuss only liquid and liquid. Solid and liquid we will take tomorrow. Gas and liquid we have already done yesterday in Henry's law. So liquid and liquid. So this is solution. Now it is solvent and solute both. So I call it solution. And I told you it is solvent is liquid as well as solute is liquid. Both are liquids. Let us close the system. Close the system and write down both the liquids are volatile. Maybe one volatile more than the other, but both are volatile. And you know, if you don't know what is volatile, you can write volatile is that which can escape into vapor form. Volatile. Both are volatile. Must to write, I have selected two liquids today. Both liquids are volatile. One liquid is A, other liquid is B. Both liquids are volatile. So the liquid which is more volatile, which has a more volatile will escape into vapor form than the other, more readily than the other, and these are the vapors going on. But as the system is closed, this we already taken in class 11, just I am repeating. This is all the vapors of this liquids, volatile liquid which is more volatile going on, but the system is closed. So the vapors, this rate of evaporation continue. But after some time what will happen? These vapors cannot escape into the atmosphere. So those vapors, a stage will come when the equilibrium will establish. The vapors will collide with each other and they struck with the liquid surface. They will struck with the liquid surface. That is the rate of evaporation. A stage will come when the rate of evaporation become equal to rate of condensation. And this stage is, you know all, this stage is called equilibrium state. Rate of condensation. Rate of evaporation and rate of condensation become equal, the equilibrium stage comes. So what is vapor pressure? It is a pressure exerted by vapor. Vapor pressure is a pressure, write down the statement. Vapor pressure is the pressure exerted by the vapor over the liquid surface. It is a pressure exerted by the vapors over the liquid surface at equilibrium. At equilibrium. This is vapor pressure. Vapor pressure always comes when there is equilibrium stage is there. This is all about introduction of vapor pressure. So now I am taking the detail of topic vapor pressure of liquid solution. This is studied by scientist Raoult. Write down R-A-U-L-T, Raoult's law. So today your main topic is Raoult's law. When both liquids are volatile, this case is studied by scientist Raoult. So let us start with the topic Raoult's law. Write down in detail Raoult's law. This is general introduction of vapor pressure. This is just definition of vapor pressure. I think you have written vapor pressure is a pressure exerted by the vapor over the liquid surface only at equilibrium. Now Raoult's law. Now according to Raoult's law, now you write 2 lines, make 2 columns. I take slowly. Let it is my A liquid, let it is liquid B. Write down A and B. There are 2 components A and B. Repeating I am, both are volatile. According to Raoult's law, small letter p is a partial pressure of this A. This is partial pressure of B. According to Raoult's law, partial pressure of any component in a solution is directly proportional to its own mole fraction. Its own. Write down. It is PA proportional to XA, PB proportional to XB. You may take A is equal to 1, B is equal to 2. That is your wish. Either you take 1, 2 or you take AB. So both A and B are my components. Both are volatile. According to Raoult, right here, according to Raoult's law, the partial pressure of any component in a solution is directly proportional to its own mole fraction. Now let us start side by side. This is PA is equal to KXA. This is PB is equal to KXB. Now write down in case of pure liquid. In case of pure liquid, same you write here. Write along with me. So Raoult's law is little difficult written in NCERT books. So it's very simple way I am taking. In case of pure liquid, write down in both sides in case of pure liquid. Now what meant by pure liquid? Pure liquid means you have only one component A. You have not any component B here. You have not dissolved these two. They are separate. A is separate, B is separate. After that I will mix these two. Just I have not prepared the solution. This is my 1, this is my second component. So XA is equal to 1. X is equal to 1, XB is equal to 0 here. And in this case, XB is equal to 1. Put this value here. This is your equation number 1. This is your equation number 1 in this case. Put X and XB value in equation 1. And this comes PA is equal to K into 1. The moment you will write here 1. 1 means pure liquid. You will write here naught. This naught stands for pure state. Pure. You have only A. Pure means you have only one component. Not you have dissolved the other component yet. Not pure. Pure. It is a pure. This means when the pure state is there, you will write here 1 and here you write naught. This comes K is equal to P naught A. Similar way. Now write. Put here. This XB is equal to 1, put in equation 1. This comes PB is equal to K into 1. The moment you will write here 1, you write here naught. This comes K is equal to P naught B. This is the value of the constant. Now put K in again equation 1. And this comes, put K in equation 1. This is PA is equal to P naught A XA, and this comes PB is equal to P naught B XB. Round it off. There are so many numericals. Whatever I will round, that formula will take the numerical part, right? Now, no demarcation now. I am going to mix these two. PS is equal to PA plus PB. This statement is given by Dalton's law last year. According to Dalton's law, the total pressure of the solution is the sum of the partial pressure. Now, this is Raoult's law. Now, what Raoult's law statement is? Now, you can please see my pen, where my pen is going. According to Raoult's law, the partial, P for partial, the partial pressure of any component in a solution is equal to the product of the mole fraction of the same component and the partial pressure of that component in the pure state. This is a statement of Raoult's law. When by notes will come, you can learn this statement, or no need to learn, understand. Again, listen. Partial pressure of any component in a solution is equal to the product of the mole fraction of the same component and the partial pressure of the component, but in the pure state. This is a statement of Raoult's law. So after that, now I'm going to mix these A and B because both are volatile. You can write A and B, both are volatile. It's a derivation, heading, put the heading, derivation of Raoult's law when both are volatile. Both are volatile. When both are volatile, so PS is equal to PA plus PB. Put the value of Raoult's law. PA is equal to P naught A XA. PB is equal to P naught B XB. We have taken the help of little Dalton's law, because according to Dalton's law, the total pressure of the solution is the sum of the partial pressures and so on. Now, PS, this is Raoult's law. PS is equal to P naught XA plus P naught B XB. Simplify it. PS is equal to P naught A. XA is 1 minus XB. Or you may put XB is equal to 1 minus XA. First I have taken. Plus P naught B XB. I think it is clear. I am going to rub it. After that, the next step, I am going to open this bracket. Now you can see this is your Raoult's law. Again, listen to me. But we are taking today vapor pressure. Do you know what is the vapor pressure? It's the pressure exerted by the vapors over the liquid surface only then when the system is closed and when there is a stage of equilibrium. This was the last year topic. Now today I have taken Raoult's law. Now what is Raoult's law? According to Raoult's law, partial pressure of any component is directly proportional to its own mole fraction. So that comes derivation PA. This is Raoult's law. PA is equal to P naught XA. PB is equal to P naught B XB. This is Raoult's law. Raoult's law. Now we have started derivation of Raoult's law when both components are volatile. Now we have mixed and removed this line. A and B were separate first. So that's the reason I written pure liquid. Pure liquid means you have only A. Pure this side pure liquid means you have only B. You have not mixed A. You have not mixed B. But now there is no line. Now going to mix these A and B. Both are volatile. Let us see what will happen. PS is equal to PA plus PB. Now open this bracket. PS is equal to P naught A minus P naught A XB plus P naught B XB. Now what you will do, common, you can take, its PS is equal to P naught A plus XB is common, and now inside the bracket will come P naught B minus P naught A. You can write this. This is the final answer. Now I am going to rub it. When both components are volatile, this will come. PS is equal to P naught A plus XB, P naught B minus. This is the final answer of this Raoult's law. And do you know this equation is resembles with the equation of straight line. Y is equal to mx. This is slope. Just now I will draw a graph. Mx plus c. This equation resembles with the equation of straight line. Y is equal to mx plus c. Now in this equation, round it off. In this equation, P naught A and P naught B are the constants. Right? P naught A and P naught B are the constants. This is constant, this is constant, this is constant. So what does it prove? It proves the total vapor pressure of the solution. The total vapor pressure of the solution is the linear function of, is proportional to, I means proportional to, is a linear function of the mole fraction of B or 1 minus XA. You may write XA. Again listen, what this proof? The total pressure of the solution is the linear function of mole fraction of the component B or 1 minus XA, one and the same thing, because this is constant, and this is constant. So what left? So if you plot a graph by taking y-axis, on y-axis vapor pressure, on x-axis mole fraction, you will see a straight line. Now let us start with the graphical part. Now draw a graph along with me under this. Draw a graph. I think it is clear now. We have opened the bracket. Just bracket, you can see this comes and this occasion resembles with the occasion of straight line. Now draw a graph. Because graph carrying both components A and B, so we will draw a graph like this. Draw a graph along with me. It is little complicated graph. Both axes are taken. Why? Because this side is for my A, here no B at all. X is equal to 1, XB is 0. Here XA is equal to 0 this side and XB is equal to 1. This is your mole fraction, XB, or you may write 1 minus XA, mole fraction, XB. XB mole fraction going to increase this side. This is your vapor pressure, total pressure of the solution, PS it is, vapor pressure. Now, what you will do? You know, I think you came to know these are two y-axis, one for A component, other for B component. Write down. When there is 1, x is equal to 1 means this, you have the only A component and it is maximum. When it is maximum, your pressure is maximum. The moment, draw a graph along with me. When XA approaches 0, the vapor pressure also going to decrease. 0. Vapor pressure 0 because XA is 0. And this is your P naught A. Write down here P naught A. This is vapor pressure of the pure component A. And write on this line, it is PA is equal to P naught A XA. It is PA is equal to P naught A XA. Now, other same side. Now, XB is equal to 1. That means this is the y-axis of your component B. Now, what you will do? Now, this is your, when XB is equal to 1, the vapor pressure is more. When moles of B decreases, vapor pressure going to decrease. Vapor pressure when XB is 0, vapor pressure becomes 0. Now this is PB is equal to P naught B XB. Please write along with me. And this is your P naught B. Now this is all about. Now this is your slope. This is your line number 1. This is your line number 2. Now you will add these two. This comes. Now draw a solid line. This is PS is equal to PA plus PB. This is PS is equal to PA plus PB. Now students, I think one question must be in your mind, why I have written little above this point P naught B and P naught A little down. Because one, you can write here B, by assuming it, B component, assume B component is more volatile than A. Assume it, B component is more volatile than A. And also the second reason is, If the B component is more volatile, then it has more pressure, more vapor pressure. So I'm showing more vapor pressure of B because I assumed my B component is more volatile than A. Second is, on the top of this graph, one equation I derived, you can see that equation. I think that equation was, in the equation, what was the slope? Check what was the slope. Slope was P naught B minus P naught A. You can check. Slope was, I've written M. Above them I've written P naught B minus P naught A. Slope is positive, P naught B minus P naught A. So P naught B just at the higher level, P naught A is the lower level. So slope is positive, P naught B minus P naught A. So those solutions which can make this type of graph in which both components are volatile, those solutions are called ideal solution. This is one of the ideal solution. Ideal solution topic I will take within 1 or 2 days. So ideal solution is that which obey Raoult's law. Write down. Again I will take within days. Ideal solution is that which obey Raoult's law. So if question comes, draw a graph of the ideal solution, you will draw this. So this graph will used at 2 places. When the derivation comes, derive Raoult's law. When solute and solvent, when both the components are volatile, then you will use this graph. If the question comes, draw a graph to show the solution is ideal, then you will draw this graph. So this is a question. So this graph used at 2 places, one of derivation of Raoult's law and the second is of ideal solution. So this is a graph of the ideal solution. So this is Raoult's law. Now there are many of the numericals of the Raoult's law. Let us start with the numericals of the Raoult's law. It's a very important numericals of the Raoult's law. Before taking the numericals of Raoult's law, I am writing few formulas. What formulas you will use? I think it is clear. Even then I am taking again, write down conclusion, what topic I have covered, conclusion of Raoult's law. It is PA proportional to XA. I think it's clear. It's conclusion I am just taking. A or B. Is PA is equal to KXA. In case of pure liquid, put here 1. And when pure liquid is not, it's K. This means K is equal to P naught A. You put here, this comes PA is equal to P naught A XA. I think it is clear now. This is Raoult's law. This is Raoult's law. This is a composition of the in the liquid phase. So this formula you will use today in the numericals. It's a numerical part. Sooner I will take. After that, now you know, just now I draw a diagram. This is my diagram. When I started my lecture, I draw a diagram showing this is liquid phase, showing this system is closed. This is my vapors. This is my vapors. So remember students, always remember, when the question comes, calculate the composition in the liquid phase. Then you will write XA and XB. When the question comes, calculate the composition in the vapor phase, then you write Y and YB. Remember this, composition in the liquid phase when comes, you will calculate XA from here. XA from here. But when the question comes, calculate the composition in the vapor phase, then there is no formula I would write. Y and YB. Now, Y and YB from where it will come? You can also write this is only for numerical purpose, no theory. Because the theory we have already done in class 11th in our Dalton's law. Now write down how to calculate Y and YB. Just write just simple formula of Dalton's law. But Dalton said the partial pressure of any component in the vapor phase is equal to total pressure multiplied by its mole fraction in the vapor phase. If it is A, it is A. Again listen, Dalton's law. Partial pressure of any component in the vapor phase is equal to total pressure and multiplied by the mole fraction in the vapor phase. Now you can calculate YA is equal to PA by P total. So this is the formula. YB is equal to PB by P total. Either you can write YA plus YB is equal to 1 and YV is equal to 1 minus YA. This is very simple. So remember students, XA and XB is the mole fraction of the components in the liquid phase. YA and YB are the mole fraction of the components in the vapor phase. This is all about Raoult's law. Raoult's law become a special case of Henry's law. You know Raoult's law and Henry's law is one and the same thing. Just there is difference in the proportionality. PA is equal to P naught A XA is Raoult's law. PA is equal to KH XA is Henry's law. We do not forget it's Henry's law. So Raoult's law become a special case of Henry's law when P naught A is equal to KH. It's a very important question. When does Raoult's law become a special case of Henry's law? Answer is one word answer, when P naught A is equal to KH. Write down your question. When does Raoult's law, this is your Raoult's law, this is Henry's law. When does Raoult's law become a special case of Henry's law? The answer is when P naught A is equal to KH. I think everything is clear. Now I've given the conclusion, vapor pressure, Raoult's law. Now you left with only numericals of the Raoult's law. Numericals of the very simple numerical. Now you open the NCERT book. In the NCERT book there is a very important numerical. You first take in-text numerical. This is your numerical number. Open your NCERT. So this is your numerical number is 8th numerical in NCERT. In-text 8th numerical. Let us start 8th numerical. Open your NCERT because I am not going to dictate the statement. The vapor pressure of pure liquid A, when the movement is pure given, you write not. The vapor pressure of pure liquid A is 450 mm. The vapor pressure of pure liquid B is 700 mm. The question is find out the composition in the liquid phase. In the liquid phase as well as in the vapor phase. Very important numerical it is, and it's covering all things. I think if I will take one numerical, you can attempt so many numericals. This is a one numerical like this. So when the total pressure is given, it is 600 mm. Write down. Partial pressures of A and B are 450, 700. You have to calculate the composition in the liquid phase and the composition in the vapor phase. Partial pressures are given, total pressure is given. Let us start Raoult's law by applying Raoult's law. P total, start with a numerical. P total is equal to PA plus PV. Yesterday I shared each step has marks. So half mark will be awarded to you for this step. P total is 600. Write down 600. Now what about PA? You can put Raoult's law. PA is equal to P naught A XA and PB is P naught A XA and PB is P naught B XB. This is a derivation come numerical. Derivation plus numerical. Derivation and calculation both it is carrying. So it is literal derivation. PA is equal to P naught XA. PB is equal to P naught XB. Put your P naught A. Your P naught A is 450 mm. Put here 450. It is 600 is equal to 450 into XA plus P naught B is 700 and put here 1 minus XA. This is all about very simple. I think you can easily calculate. This is your 600. It is equal to 450 multiplied by XA plus 700 1 minus XA, and you can calculate XA. Now you can calculate XB as well. How? XB is equal to 1 minus XA. After calculating X, this is your first answer. This is your second answer. Now what about the third and fourth, Y and YB? Now I'm taking this. After calculating XA and XB, after that what you will do? You will calculate PA and PB again. Because PA is equal to P naught XA and PB is equal to P naught BX. You will put the value, you will get PA and PB. Whatever P naught A is 450, you put 450. Whatever XA it will come, you can put here. Your PA will come. Similar way, you put P naught B, you put XB, your PB come. Why I need this? Because I want PS. PS is equal to PA plus PB. Next step, stepwise. This is your third step, this is fourth step, this is fifth step. Now after that 6 is YA. You know what is a YA? YA is PA, you can take from here, divided by total pressure. This is your sixth step. And seventh step, YB is equal to 1 minus YA. This comes answer. Very important and very simple numericals of Raoult's law. Now you can take numericals. Now you write down. You will take one numerical at your home. Very important numerical. It is example. You please note down your example number 5. You must attempt example 5 after this. Even there is a very important numericals in the exercise. Exercise numerical you attempt yourself. Numerical number is 36. 36. If you successful in attempting these two numericals, Raoult's law is very simple. It's clear. So this is all about Raoult's law. There are one or two numericals are also there. We will take those when we will start with the topic ideal solutions. So this is all about. Now tomorrow we will start vapor pressure of, write down, vapor pressure of solid and liquid. Today discussed liquid and liquid, solid and liquid. After that we will start ideal and non-ideal solution tomorrow. So this is my request to all of you. Kindly attempt two numericals of Raoult's law at your home surely. Only then you get satisfied that your Raoult's law is clear or not. This is all about today's lecture. Hope you liked, understand it. Only then you can well understand if you have NCERT and my notes. This is my first condition. Before taking my lecture, you must have NCERT in your hands as well as must write each and every point. I am giving you a very simple lecture, very simple. So enjoy, learn and enjoy. Stay home, stay safe. Thank you. Subscribe my channel surely. Thank you.